Welcome to Hexagon Tutorials Dart series. In this part, we will understand inheritance in object-oriented programming. Inheritance is one of the core principles of object-oriented programming, and it allows a class, known as the child class or subclass, to inherit properties and behaviors from another class, known as the parent class or superclass. This means that the child class automatically gets access to the attributes, that is, variables, and functions defined in the parent class without needing to rewrite them. Let's understand inheritance with a real-life example. Imagine a father and son relationship. The father has certain characteristics like a last name, family values, and wealth. He also has some abilities like working to earn money and guiding the family in important matters. Now, the son is born into the same family. Since he is part of the family, he automatically inherits the last name, the family wealth, and the values from his father. He also learns how to work and guide the family from his father. However, the son may develop his own unique characteristics. Perhaps he is good at playing sports, which is something his father never did. How this relates to programming. In programming terms, the father is the parent class, that is, superclass, which contains common properties and methods that can be used by its children. The son is the child class, that is, subclass, which automatically gets all the properties and behaviors of the parent, but can also introduce new ones or modify existing ones. Benefits of inheritance. Code reusability. Instead of defining common properties and methods in every class, we define them once in a parent class and reuse them in child classes. This reduces redundancy. Hierarchy and organization. It helps establish logical relationships between classes. Just like in a real family, where traits pass from one generation to another, inheritance allows us to build a structured system in our code. Method overriding, that is, customization. A child class can modify or override the methods of a parent class to change its behavior. For example, if the father's method of working is different from the son's, the son can redefine the work method in his own way. A quick example in simple terms. If we create a class called father with a method work, and then create a class son that inherits from father, the son will automatically have access to the work method. However, if the son wants to have a different working style, he can override the work method and define it in his own way. This is how inheritance makes programming more efficient, organized, and easier to maintain. Let's understand this concept step by step. In this example, we have two classes, animal and dog. The animal class is the superclass, which means it serves as the base or parent class. It has a general behavior, which is making a sound. Then, we create a dog class, which is a subclass of animal. This means the dog class inherits all the properties and behaviors of the animal class. However, the dog class also has its own unique behavior, barking. To establish this relationship, we use the extends keyword. This tells Dart that the dog class is inheriting from the animal class. Now, when we create an object of the dog class, it automatically has access to the method from the animal class, even though it was not explicitly defined inside the dog class. Along with that, the dog class can have its own additional methods. When we run the program, the dog object is able to perform both actions, making a general animal sound inherited from the superclass and barking, which is specific to the dog class. This is the power of inheritance. It helps us avoid repeating code and allows us to define shared behaviors in a parent class while letting child classes extend or customize that behavior as needed. This code demonstrates inheritance in Dart. The animal class serves as the superclass with a property name and a method speak. The dog class extends animal, inheriting its properties and methods while also introducing a new property breed. In the dog class, the super keyword is used to pass the name parameter to the animal constructor. The display method prints the dog's name and breed. In main, an object of dog is created with the name Goldie and breed Golden Retriever. The object calls speak, which it inherits from animal, and display, which is unique to dog. Let's now understand method overriding in object-oriented programming. Method overriding allows a subclass to provide its own specific implementation of a method that is already defined in its superclass. When the method is called on an instance of the subclass, the overridden version is executed instead of the original one. Key features of method overriding. First, the method in the subclass must have the same name, return type, and parameters as the one in the superclass. Second, we use the @override annotation to explicitly indicate that a method is being overridden. Though it's optional, it improves code readability and ensures that we are correctly overriding a method. Finally, method overriding allows us to customize the behavior of inherited methods, making the subclass more specific and functional. Why use method overriding? Method overriding is essential when we want a subclass to behave differently while keeping the same method structure. It supports polymorphism, meaning that the correct method is executed based on the object type at runtime. And lastly, it makes the code more flexible and reusable by allowing modification of specific parts of an inherited method rather than rewriting the entire class. This is how method overriding helps in writing efficient and structured code in object-oriented programming. Let's understand this code and how the super keyword works in Dart. We have a superclass called animal, which has a variable named name and a method called makeSound. The makeSound method prints a generic message that animals make different sounds. Next, we have a subclass called dog, which extends the animal class. In the constructor of dog, we use super.name to modify the value of the name variable inherited from the superclass. This means whenever we create a dog object, it automatically updates the name property to dog. Inside the displayInfo method, we use super.name to access the inherited variable from animal and we print it. We also print the breed of the dog, which is a property specific to the dog class. Finally, we use super.makeSound to call the makeSound method from the animal class, which prints the message animals make different sounds. In the main function, we create an object of dog, passing the breed golden retriever. Then we call displayInfo, which prints the animal type, breed, and the inherited sound message. So, in summary, the super keyword allows the subclass to access and modify inherited properties and call methods from the superclass. In this example, we are demonstrating method overriding in inheritance, specifically how we can override getter and setter methods in a subclass. We start with the employee class, which has a private salary variable to enforce encapsulation. It provides a getter for bonus, which calculates 10% of the salary, and a setter for salary, which ensures the salary cannot be set to a negative value. Now, we create the manager class, which extends employee and overrides both the getter and setter. The bonus getter is overridden to return 20% of the salary instead of 10%. As managers receive higher bonuses, the salary setter is also overridden. Unlike regular employees, a manager's salary must be at least 5,000. If a lower value is assigned, an error message is displayed. Instead of updating the salary finally in the main function, we create an employee and a manager object. We print their respective bonuses. We update the employee salary. Using the setter, we try to set an invalid salary for the manager, which triggers an error message due to the overridden setter. One important fix in this code is that we should not access the salary variable directly in main because it is private. Instead, we should use a getter for salary. This ensures proper encapsulation and follows best practices in Dart. In this quick recap, let's go over the key concepts of inheritance in Dart in detail. First, we have the extends keyword. This is used when we want a class to inherit the properties and methods of another class. The class being inherited from is called the superclass, and the class that is inheriting is called the subclass. This allows us to reuse code efficiently instead of writing the same methods and properties again in every class. By extending a class, the subclass automatically gains access to all the non-private properties and methods of the parent class. Next, we have the @override annotation. This is used when we want to change the implementation of a method that we inherited from the superclass. While this annotation is not required, it improves code readability and ensures that we are correctly overriding a method. If the method signature does not match the original method in the parent class, the compiler will generate an error, preventing mistakes. Overriding allows subclass to provide their own custom behavior while still maintaining the same method structure. Now, let's talk about the super keyword. This keyword is essential when working with inheritance because it allows a subclass to directly access properties and methods of the superclass. For example, if the parent class has a method that we still want to use but also want to add something extra to it, we can call super.methodName inside the subclass method before or after adding our custom behavior. Similarly, the super constructor can be used to pass values to the parent class when creating an object of the subclass. Finally, we also have the concept of inheriting and overriding getters and setters. Getters and setters allow controlled access to private properties. When a subclass overrides a getter, it can modify the way data is retrieved. Similarly, overriding a setter allows us to add additional validation or conditions before modifying a value. This is useful when different classes need different rules for handling data, while still using the same method names for consistency. By understanding and implementing these concepts, we can write more flexible, organized, and reusable code using inheritance in Dart. Thanks for watching this video. Do like, share this video, and subscribe to our channel.